We're going to look at two types of tests. Both of them involve comparison. The first one is simply called the comparison test. The comparison test is as follows. Let AK and BK be two series with positive integers. The comparison test tells us that if the terms AK is less than BK for each K, and the series BK converges, then the series AK has to converge. It also tells us that if AK is greater than or equal to BK and BK diverges, then AK diverges. This is a theorem that involves some slightly rigorous proof, but we're not going to worry about proving it. Let's just explore it intuitively. So we have two series here. I mean, some people say series is for the plural of series, but I think it's just series. So we have two series here. One of them is larger than the other. So think about it. If AK is less than BK, this means that BK, the series BK, its sum is going to be larger than the series AK, right? Any partial sum is going to be larger. All right, so if BK is greater than AK and BK converges, then AK converges. So if the big series converges, then the small series has to converge. Now, if AK is greater than BK and BK diverges, then AK must diverge. So we have AK greater than BK and the small series diverges, then the big series better diverge. I hope this is making sense to you guys. All right, so let's do some examples right away. So let's determine convergence or divergence. Does it converge? Does it diverge? So we have summation k from 1 to infinity of k cubed over 4k to the power of 4 minus 1. All right, this involves some algebra or some knowing your fractions. All right. Now, if you have k cubed, so let's look at two things. So look at this. Call this your AK. Now I'm going to look at my AK, right? So my AK now my AK is equal to k cubed over 4k to the power of 4 minus 1. Now, you have 4k to the power of 4 minus 1, right? I'm going to compare this fraction k cubed over 4k to the power of 4 minus 1. I'm going to compare it to k cubed over 4k to the power of 4. So, why am I comparing it? This particular denominator is smaller than this denominator. So that means that this whole fraction is going to be larger than this fraction. So I'm going to do this. This AK is larger than k to the power of 3 over 4k to the power of 4. So I'm going to call this my BK. Okay. So I'm going to compare my series. I'm going to go on here and I'm going to compare my series with k to the power of 3 over 4k to the power of 4. Okay, so that's what I'm doing. Now let's look at this series I just wrote down. I don't know why I wrote it in red, but it just feels good to write out there. So this series, so I'm just rewriting the stuff I wrote in red. So compare with k from 1 to infinity, 1 over 4k, right? Which we can think about as, this series is actually, think of it as k to the power of 1 to infinity, 1 over 4 times 1 over k. But this is a summation, so we can factor out 1 over 4 from each of the terms. So I get 1 over 4 summation k from 1 to infinity, 1 over k. This is like 1 over 4 times the harmonic series, which we know diverges. So multiplying it by 1 over 4 means it's going to still diverge. You have a divergent series, you're multiplying by a constant, it still diverges. It doesn't matter what constant you multiply with. It could be 0.00000001. It's still going to diverge. So it diverges. So let's go back. We have AK greater than BK, and BK diverges. Therefore, AK must diverge. Therefore, BK diverges, so AK must diverge. So our series, k from 1 to infinity, k cubed over 4k to the power of 4 minus 1, must diverge by the comparison test. All right, another example. So how about the summation k from 1 to infinity of natural log of k over k? Natural log of k over k. So let's start our comparison. Our AK here is natural log of k over k. Natural log of k over k. Natural log of k, if k is 1, natural log of 1 is 0. If k is 2, natural log of 2 is sort of, what is it? Let me see. Let me check. What's natural log of 2? I hope I'm not wasting your time. Natural log of 2, what is it? It's like 0.69. But natural log of 3, let's see what natural log of 3 is. Natural log of 3 is 1.09. So from 3 and above, well, let's see natural log of 4. Natural log of 4 is 1.386 something. So from 3 and above, natural log of from k from 3 and above, natural log of k is greater than 1. Definitely greater than 1. So 1 over k. So natural log of k is greater than 1 over k. So this is our BK. And for k equals 3, 4, and above. So I just want to mention something. Whenever you have a sequence or a series and k starts from, say, 1 to infinity, and you're able to work with something from k greater than 1, let's say k from 3, k from 4, k from 1,000, you can just forget about what happened from 1 to 1,000, all right, or 1 to 3, and worry about what happens from 3 and above, or 1,000 and above. And whatever result you get from 1,000 and above or 3 and above should work for the result you get from 1 and above. So what am I saying? I'm saying that we have this result, which we're going to continue. Let me continue and then finish it. So we're going to compare to, I don't know, k from 3 to infinity of 1 over k, which is the harmonic series starting from 3, right? So this is the harmonic series. Which diverges. So what am I saying? I'm saying that we worked from 3 and above, but it's good enough, even though our original series starts from 1 and above. So harmonic series diverges. We have a series which is larger. AK is larger than BK, but BK, which is a smaller series, diverges. So AK, which is a larger series, must diverge. Therefore, k from 1 to infinity of natural log of k over k must diverge. And of course, from the comparison test. Okay, now let's look at another test, the limit comparison test. It's a very, very good test, just like every series test. So I'm going to write it down. This is also a theorem that we can prove, but we're not proving it. So this is a limit comparison test. So going to say let AK and BK again be two series with positive terms. But in addition to this, let the limit as k goes to infinity of AK over BK be equal to L. So we have two conditions in this case. Now, the first result says if L is between 0 and infinity. So that means if L is less than infinity, if L is a number, right? Then AK and BK both diverge. Let's start with converges. Both converge or diverge. By the way, I have a question for you guys. Think of it and tell me in class. If you are a series, would you want to converge or would you want to diverge? Think about it carefully. There's no correct answer. I just want to know. All right. If L is equal to 0 and BK converges, then AK better converge. Then AK converges. All right, 3. If L is equal to infinity and BK and bk diverges, then ak diverges. Okay. Let's do an example. Example. How about summation k from 1 to infinity of k to the power of 4 minus 2k squared plus 3 over 2k to the power of 6 minus k plus 5. All right? Now, what do we have? Think about this carefully. Think about back to calculus. So, I want us to think. Think in green. Think in green. Maybe not in blue. And when I say green, I mean like environmentally friendly. I don't mean something else. I don't mean what you're thinking. All right. So k to the 4 minus 2k squared plus 3 over 2k to the power of 6 minus k plus 5. Now, if you remember in calculus, when you're taking limits, right, you just worry about this term and this term, the two highest terms. You don't worry about this, okay? So this will make us just think about k to the power of 4 over 2k to the power of 6, which is the same thing as k, no, 1 over 2k squared. Okay? So, what we're going to do is we're actually not even going to worry about this 2 because it's just a constant, or 1/2 over here, 1/2 over here, because there's a 1 there. It's just a constant. In order to carry out our limit comparison test, we're going to consider, so this is our AK. So we're going to consider the limit I have to move from that noise. So we have to consider the series. K from 1 to infinity over 1 over k squared. All right, so this is our AK. The limit as k goes to infinity, limit comparison test, we want to find the limit as k goes to infinity of AK over BK. So AK over BK is the limit as k goes to infinity of k to the power of 4 minus 2k squared plus 3 all over 2k to the power of 6 minus k plus 5 divided by bk. So if I'm dividing by 1 over k squared, it's like multiplying by k squared over 1. All right. So this is like the limit as k goes to infinity of k to the power of 6 minus 2k to the power of 4 plus 3k squared all over 2k to the power of 6 minus k plus 5. This is limit to infinity. So remember, from Calc 1, you don't even worry about this. You don't worry about this too. All right? You just look at this. Look at the coefficient of that and 2. If the two exponents are the same, these two exponents are the same, then you just have to worry about the coefficients in front of k. So that tells us that this limit is equal to 1/2. All right, think about, let's go back to the limit comparison test. If limit is greater than 0, then either both series converge or both series diverges. All right? So, what do we know about this series? I call this AK. Sorry, it should be BK. Oh gosh, I feel like rewinding and deleting what I just said in this video, but this is BK. So this is our BK. Okay. What do we know about BK? This series converges. Why? Why? It's a P series. Why? Because P is greater than 1. All right. So therefore, this limit is 1/2, and limit comparison test says that if the limit is greater than 1/2, if one converges, the other should converge. We can now happily conclude that by the limit comparison test, this summation, this whole thing, I'm gonna just copy this because I don't feel like writing it again. Copy, paste it here. Oh shoot, it didn't work. That's weird. Okay. Copy, paste. All right. So this series converges. We're gonna stop here. I will talk to you in class.